All right, so now that we know how to do some of our conversions, right, between our SI units with our metric conversions, now we can start doing some calculations with our photoelectric effect, okay? So let's go through a couple of these examples right here, right? So the first one, right, a photon of light is released from helium at 492 nanometers. What is the frequency? Okay, so all of our photoelectric effect, first off, I'm going to write my equations up on top here. I've got E equals HF and C equals lambda F, okay? And I know that H equals 6.626 times 10 to the negative 34th joules seconds, and I know that C equals 3 times 10 to the 8th meters per second, okay? So I'm going to take, and I read the question, I immediately see, well, first off, I'm going to see that 492 nanometers is going to be somewhere that I'm going to start, okay? Whoops, 492 nanometers, okay? And I want to get over to the frequency. So 492 nanometers is a wavelength, and I'm wanting to get to a frequency, so I'm going to want to use C equals lambda F, okay? But when I do that, I see, oh, my speed of light is meters, and I have nanometers. So I need to convert my nanometers to meters before I can use this equation, okay? So if I take my 492 nanometers, I'm going to convert it, right? I can put it either in brackets or you can build your grid, but I'm going to say, okay, well, I have nanometers. I want to get up to meters. How many nanometers are in a meter? I don't know right now. But I know that 1 nanometer, and if I go over to my table in my note packet, I can come down here and I look and I see, okay, nano, there's my prefix, and I've got meters, or I want to go to meters. 1 nanometer is 10 to the minus 9th meters, okay? So this exponent is what I can put on there, okay? So 1 nanometer is 10 to the minus 9th meters, all right? So if I do that, that's going to convert my nanometers to meters, right? There's my conversion, and I can see that I'm going to have 4.92 times 10 to the minus 7th meters. Now I can take my wavelength and put it into this equation, and I can calculate my frequency. So my frequency, right, my frequency is going to be, if I rearrange this, it's going to be C divided by lambda. Okay, so I put that in there. Well, C is 3 times 10 to the 8th meters per second, and I can divide it by 4.92 times 10 to the minus 7th meters. But now this fits appropriately, but then I have this weird fraction on top with my units. So what I can also do, this might help us see that our units are going to cancel, is I'm going to do this, right? I can say, well, 3 times 10 to the 8th meters per second. I'm going to put my grid on. I want to divide by my 4.92 times 10 to the minus 7th. So this is the same as multiplying by 1 over 4.92 times 10 to the minus 7th meters. Now we can see that my meters are going to cancel with my meters, and I'm going to be left with 1 over seconds for my units, right? And if I then do my calculation, right, I do 3 times 10 to the 8th divided by 4.92 times 10 to the minus 7th, that's going to give me 6.10 times 10 to the 14th per second, which is the same thing as hertz, okay? So my answer, my frequency, is 6.10 times 10 to the 14th hertz, okay? All right, let's look now at this next question here. This is another example one for us here. A photon with 9.72 times 10 to the minus 19th joules of energy is released. What is the frequency? Okay, so I'm going to start for sure with 9.72 times 10 to the minus 19th joules. I always, whenever I read a question, I'm going to pull out any sort of numbers that I see in the question. Okay, so I know that I have this energy and I'm going to try and get to frequency. For me to do that, I'm going to have to use E equals HF. All right, so E equals HF, I need to get to frequency. Well, frequency, right, I need to rearrange my equation, but I can see that it's just E divided by H. So I have joules here. If I look at H, that's joules seconds, so that's going to convert nice and easily. We don't actually have to change my units at all. So frequency is going to be E divided by H. Let me just plug in my numbers now. E is 9.72 times 10 to the minus 19th joules, and I'm going to divide it by 6.626 times 10 to the minus 34th joule seconds. And what I can see here, again, is that joules divided by joules is going to end up giving me the appropriate units for frequency, right? I can also, if I wanted to put it in like that, I can, right? I would do 9.72 times 10 to the minus 19th joules, and then I want to convert, so I'm going to do 1 divided by my number, right? It's the same. If I want to divide it here, it's the same as multiplying by 1 over the number. So 6.626 times 10 to the minus 34th joules seconds. Right? I put that on there, and I can see joules is going to cancel with joules. So my overall number is, my answer at the end is going to have per second, which is my hertz, which is a frequency. So then if I come onto my calculator here, let's see if we can get this to be seen. There we go. So if I take this, right, 9.72 times 10, I'm going to do my EE button there, times 10 to the minus 19th, and then I'm going to divide it by, I'm going to put this in parentheses, 6.626, again use my EE, times 10 to the minus 34th, put the parentheses at the end. There's my answer. And I've got 1.46, or I'll do 1.47, right, if I round appropriately, times 10 to the 15th hertz. Okay? So we've gone through 2 of them here now. Hopefully you can work through the rest of these questions. Okay?